This nutshell shows structure diagrams and state diagrams. We show structure diagram symbols and how they operate and how the state diagram operates. And I show examples of both structure and state diagrams. And if you do find this nutshell useful, please support the channel by liking the video and subscribing. Your support helps create more content like this, and you'll stay updated with new tutorials and knowledge. When writing a design structure diagram, we use the symbols shown here. The designator shows the start and end of the diagram. A process is shown as a rectangular block. The diamond is used in decision statements. If the condition is true, run the code to the right of the diamond. If the condition is false, run the code at the bottom of the diamond. The if decision box has a condition in the box. If the condition is true, run the code to the right of the diamond. For the if else, the test condition is in the box. If the condition is true, then run the code to the right of the diamond. If the condition is false, run the code at the bottom of the diamond. The switch has a condition box at the top and the cases on the left hand side. If the case matches the condition, then run the code to the right of the diamond. We have loop structures, while, do while, and for. We show the condition at the top of the box in the loop structure, and we run the code while the condition is true. And finally, we have a function which has the double lines on each side. The DSD shows the program flow. We read from the top to the bottom, left to the right. We begin at the start box, then move down the line until it intersects a horizontal line. We move right along the horizontal line, executing the sequence of instructions. Then we go back to the previous vertical position and move down to the next section. Two examples are shown here. The first is to read and output the switch values. So we begin at the start, we follow down, we come along and execute the process. We are then coming into a while one loop. The while one loop will loop forever, and we go through this process where we read switches and write to the LEDs. The second example, we use a switch to control a LED. Once again, we go from start, follow the process, set it up, follow the process, while one. We stay in this loop, and we have an if statement. If the switch is on, if that's true, then we turn the LED on, else we turn the LED off. A second example of the DSD is the washing machine. The pseudocode is written here, and the state diagram is shown here. In the while one loop, we sequentially go through a list of functions. The first one is wait. We wait for the lid to be closed, and then we wait for the start button to be pressed. In the fill function, if the hot wash is selected, the hot water goes on, else the cold water goes on, and we wait for the washing machine to become full. In the wash function, we have the wash motor on, delay, wash motor off. In the drain pump goes on, we wait for the washing machine to become empty, drain pump off. Rinse, cold water is turned on, wait for the washing machine to become full, cold water is turned off. And finally spin, we turn the spin motor and drain pump on, we delay, then we turn the spin and drain pump off. The second method of graphical design is the state machine, which can be represented with a state diagram or a state transition table. The state machine is used to design programs based on states. The program will transition between states dependent on an input or event. At any given moment in time, you can only be in one state. Normally, the outputs in the state are constant. An example of the state machine is the turnstile program. The turnstile controls access to an area using a barrier arm across an entryway. The barrier arm is normally locked to prevent customers from entering. When a coin is deposited, the barrier arm is unlocked and can rotate once to allow customer to pass through. After the customer has passed through, the barrier arm is locked and the sequence is repeated. This can be shown with a state diagram shown here, where we have two states, locked and unlocked. In the locked state, the arm is locked. We must put a coin in and it then moves to the unlocked state. We stay in here until a person moves through the barrier arm, then we go back to the locked state. Finally, we can look at the state transition table, where we have the current state, event that causes a state change, the next state, and the outputs. We can compare the state diagram and the structure diagram together with the bilge pump program. The bilge pump is found on boats and is used to pump out water that's seeping into the bottom of the boat. We have two sensors, the top water sensor, and the bilge pump will be turned on when that sensor is triggered. We also have a bottom water sensor, and the bilge pump will be turned off when that sensor is off. Looking at the bilge pump state diagram, we have two states, pump off and pump on. We move from the pump off state to the pump on when the top sensor is on, and we move from the pump on state to the pump off state when the bottom sensor is off. Similarly with the structure diagram, we can show it here. We start, set up the ports, stay in a while one loop. If the top water sensor is on, the pump will turn on. If the bottom water sensor is off, the pump will turn off. Another program is the stopwatch. The stopwatch has two buttons, stop start and lap reset. The operation is, if the clock is stopped, pushing the start button will start the clock running. If the clock is stopped, pushing the lap reset will reset the time. If the clock is running, pushing the start stop will stop the clock. If the clock is running, pushing the lap reset, the clock will keep counting, but the display will be frozen. Pushing the lap reset again will unfreeze the display. We can code the stopwatch using a state diagram. The pseudocode is shown here. We have four states, stop, run, lap and reset, and we can see the action that will occur to change the state. Looking at the state diagram itself, in the stop state, the clock is stopped. If we push the lap reset, the clock goes to 0, it's reset, and it will automatically go back to the stop state. If we're in the stop state and stop start is pressed, we go to the run, the clock is running, display is active. If we push stop start again, we will go back to the stop state. If we're in the running state, if we push lap reset, we will go into the lap state where the clock is running but the display is frozen. If we push lap reset again, we will go back to the run state. So the code structure can clearly be shown using states. We can design the stopwatch code using a structure diagram. The pseudocode is shown here, and a brief structure of the while one loop is shown here. Looking at the loop, we follow down, set up ports, while one, we stay in this while one. In this loop, the clock is not running. If the stop start is pressed, then we will go into the second loop here and stay here while stop start is not pressed a second time. We increment the count and display. If the reset lap is pressed, then we will wait for a second reset lap button press. While doing that, we will increment the count but not display. If the clock is stopped and the reset lap is pressed, we will clear the count and display. I will show you the actual code for both the state and structure diagrams when I look at the general purpose input-output registers.